Here, find an antiderivative. Before starting solve this problem, note in here when we integrate the indefinite integral, the antiderivative gonna be in form of f of x plus c, and that called a family of antiderivative since c can be any number in here. In this problem, we are asked to find one antiderivative, so we can pick a random c when we find indefinite integral. So for part 1, we have p of t equal to t cubed minus t squared over 2 minus t. Here, we're going to integrate p of t. That's going to be equal to the integral of t cubed minus t squared over 2 minus t dt. Now, we're going to use the integral of sum. So the integral of sum of functions is equal to the integral of each of these functions. Therefore, the integral gonna be the integral of the first term, and then the integral of the second term, and then the integral of the third term. Here, note that we have a multiple constant for the second integral on the third integral, so we're gonna pull that constant out of the integral. Now we are ready to integrate. So here I'm gonna use the integral of t to the n dt gonna be equal to t n plus 1 over n plus 1 and then plus c. I'm gonna take the first integral. Note it's the integral of t to the 3 dt. Therefore n gonna be equal to 3. The resulting gonna be equal to t3 plus 1 over 3 plus 1 plus c. That's gonna be equal to t4 then over 4 plus c. Now I'm gonna take the second integral. It's the integral of t to the 2 dt. Therefore n gonna be equal to 2. Now I'm gonna apply the rule. Gonna be t to the 2 plus 1 over 2 plus 1 plus c, and that's gonna be equal to t to the 3 over 3 plus c. Now I'm going to take the third integral. It's t to the 1. Therefore n gonna be equal to 1. Therefore the resulting gonna be t 1 plus 1 over 1 plus 1 plus c. That's gonna be equal to t squared over 2 plus c. Note in here, since we only want to find one antiderivative, I can pick any value for c. Here I pick c to be 0. Therefore, the resulting of the integral gonna be t to the 4 over 4 and then minus half multiplied by the resulting of the integral of t squared, that is t cubed over 3, and then minus multiplied by the resulting of the integral, which is t squared over 2. Now I'm gonna simplify. I'm gonna multiply for the second term half by 1 over 3. And that's our resulting antiderivative. Notice this is only one antiderivative of the function p of t. For part 2, we have f of t equal to t squared plus 1 all over t. Here, when I'm going to integrate this, I didn't know how to integrate this term. Therefore, I'm going to rewrite that term. So that's going to be equal to t squared over t and then plus 1 over t. And that's going to result in t plus 1 over t. Therefore, the integral of f of t dt going to be the integral of t plus 1 over t dt. I'm going to use the sum of the integral equal to the integral of each function. First, I'm going to integrate the first function. Note here, I'm going to use the integral of t to the n dt equal to t to the n plus 1 and then over n plus 1 plus c. Therefore, the integral of t to the 1 dt, here n equal to 1, it's gonna be t of 2 over 2 plus c. Now let's integrate the second integral. I'm gonna use the integral of 1 over t dt equal to the natural log of the absolute value of t and then plus c. Remember here, we only want one antiderivative, therefore I'm gonna pick c equal to 0. Again, you can pick any value for c. Therefore, the resulting integral is gonna be equal to t squared over 2 and then plus the natural log of the absolute value of t, and that's one antiderivative of t.